So what is the function of fingers? So the fingers collect the DC generated current. DC current, which is the electrons. You can see that we have large number of free electrons. So how can we collect this? We collect them using the fingers. It collects all of the negative electrons, free electrons generated by the sunlight, and it delivers them to the bus bar. Okay, it delivers them to the bus bars. Okay, then we will have the bus bar itself, which have large number of electrons, will be connected with other bus bars to increase the total output voltage of the panel. So we find that each one cell, each block of this one has a voltage generates a voltage between 0.5 and 0.9 volt. So when we connect these panels in these cells in series, we will be able to increase the total voltage. And the cells are connected in parallel to increase the total current. So how can we achieve this? By using something which is called the tap wires and bus wires. So if you look at here, we have one cell here, another cell, another cell. You can see we have this bus bar and another bus bar, another bus bar. Now you can see this one and this one and this one. Now this one generates, let's say, 0.5 volt. And this one generates 0.5 volt. And this one generates 0.5 volt. So when we connect them together like this, you will find that the total voltage, since they are in series, will be 1.5 volt. So we increased the total voltage by connecting them together in series. Okay. So how can we achieve this? By using the tap wires. You can see this wire that connects between these two cells. This wire is called the tap wire. Okay, this wire. Okay, tap wire, another tap wire connects the cells together. Okay. Now, as you can see here, so the tap wire can be added manually or automatically to the solar cell bus bar, which connects the individual cells in series with a low series resistance. Okay. Now, what is the function of bus wire? So we have here this bus wire, as this is the tap wire, and this large bus bar. You can see it connects the cells in parallel. Now, how is this happening? If you look at here, you will find that this one have a current, let's say 0.5 ampere. And this cell also provides 0.5 ampere. This one 0.5 ampere. Okay, so this bus bar connects all of this parallel, which means that the total current inside the bus bar, I, from the nodal analysis, it will be 1.5 ampere. So the clusters of tap wires strings are connected in parallel by using the bus wires, okay, which delivers the cumulative current from all the cell to the PV junction box. Remember that the PV junction box is the final two terminals, the final positive and the final negative of the PV panel itself. Don't worry, we will see this in the next lessons. Okay. So what you will learn from here, you will learn that bus bars are connected in series to increase the total cell voltage. We connect them in parallel to increase the total current. Okay. Now the bus connected in parallel by using bus wires, connected in series by using tap wire. Now we have also different types of bus bars. So if you look at this panel, for example, you will find that 1, 2, and 3 bus bars. However, you will find another panel 1, 2, 3, 4, 5 lines or 5 bus bars. So what is the difference? You will find that we have 2 bus bar, 3 bus bar, 4 bus bar, 5 bus bar. Different configurations for PV panel. Which one is the best? So first, the 3 bus bar, it is the most common solar cell design, or the most common solar cell design involves the 3 bars, uses the 3 bars printed onto the cell. Also, we have the 5 bus bar, which is the leading trend. And you will find that the higher the number of bus bars, the better. Now, why is this? Because the high number of bus bars reduces the distance between the bus bars, which reduces the internal resistance loss. You can see that electrons would like to travel and go to this one, travel and go to the other one. However, if we look at here, we have a smaller distance. Here we have a very small distance. So smaller distance or smaller finger, it means that we will have a smaller internal resistance, which means that according to Ohm's law, we will have larger amount of current. So the high number of bus bars, it reduces the finger length, which means the finger resistance will be reduced. So additional bus bars create lower resistance between cells. You can see here more bus bars, or you can think about it that more parallel branches means the total resistance is lower. Okay, or you can think about it like very small distance, and here we have large distance. Okay, so if this resistance is R, let's say for example R over 5, smaller resistance, smaller electrical losses. So as you can see, according to Ohm's law, that as the resistance goes down, the current will go up for the same voltage, which means that the total power generated from the panel will increase because power equal to VI. So when we have larger number of bus bars, it means we will have lower resistance or higher electrical current or higher electric current, which means higher current, higher generated power. Okay. So you will find that the result of the additional bus bars is that the solar panels are about 2% more efficient than the one with lower amount of bus bars. Now the question is 2% is really effective or not? You will find that the 2% is really effective compared to the solar panels. Now why is this? Now you will find that we have different types of PV cells. We have the monocrystalline silicon solar panels, we have the polycrystalline or multicrystalline solar panels, we have the amorphous or thin film solar panels, and we have the hybrid silicon solar panels. Different types of panels which uses different type of PV cells. So in order to understand if this 2% really effective or not, you will find we will need to understand these 4 types. Okay, so the first type, which is called the monocrystalline silicon solar panel. This is a figure representing one panel which is formed of a cell like which is this one, called the monocrystalline cell. Now what does this mean? You will find that this panel is one of the most effective solar panels. Not the most effective, but it is one of the most effective, or the one which is available in the market. It has an efficiency between 15 to 24%. They are cut out from a single source of silicon. That's why they are called mono. Mono means one or single. That's why monocrystalline means that it is cut out from a single source of silicon. They require less space than other types of PV panels because they produce more energy and can produce up to 4 times more power than the thin film solar panels, which we will discuss. They also last longer and perform better at low light. Okay. The only disadvantage of this one is the cost, which means it is not the first choice for the homeowners. Okay, so you have to understand higher efficiency means it will need number of panels required to achieve a certain power will be reduced. Okay, however, low efficiency means we will need higher number of panels to achieve the same function. So higher efficiency means we will have high cost. Okay. Also, this type of panels is affected by dirt or shade, which can break the circuit. As we will learn about the shading effect, we will learn about it in the course, and you will understand how it affects our PV panels. The second type is called the polycrystalline or multicrystalline solar panels. You can see this is a multicrystalline panel. You can see it's really dirty type of solar panels. You can see not like this one. If you look at this one, really clean and beautiful solar panel. Compared to this one, you can find very random panel. Okay, why is this? Because you will find that it has a low efficiency between 13 to 16%, and the polycrystalline are often seen as a better economic choice because they are much cheaper than the monocrystalline. Here, why they are called polycrystalline? Because they are made of several types of silicon, which are melted together and then recrystallized. Okay. However, the monocrystalline is formed of a single type of silicon. Okay. However, the polycrystalline, several types of silicons are melted together and form this weird shape. Okay. The only problem of polycrystalline, it has lower efficiency, which means that we will need large number of panels to achieve the same function. So here is a small comparison between the monocrystalline and the polycrystalline. Okay, so this is a polycrystalline and this is a monocrystalline. Okay. Now another type, which is called the amorphous or the thin film solar panels, which is this one. Okay, this is called the thin film, and it can be installed in areas in which the space does not really matter. So it has an efficiency of 7%, very low efficiency, and it is considered as the least efficient on the market, but they are the cheapest option. They work well in low light, even moonlight, and they are made of a non-crystalline silicon that can be transferred in a thin film into another material such as glass. You can see here we can add it in building like this. Okay, and it can be used to convert the solar energy into electrical energy. However, it has a very low efficiency compared to the other types, the mono or the polycrystallines. The main advantage is that it can be mass produced at much cheaper cost, but it is more suitable for situations where space is not a big issue. Another the disadvantage of this one is also it is not generally used for residential purposes and will degrade quicker than crystalline cells. Okay, so usually we don't use this in the residential application or in our home. Why is this? Because it has a very low efficiency, 7%. The last type which we will discuss is called the hybrid silicon solar panels. Okay, usually you will not find them in the market. Why? Because they have the highest or the best efficiency. The hybrid solar panels are made from a mix of amorphous and monocrystalline cells to produce the maximum efficiency. Now there are a variety of types of hybrid cells, and they are still very much at the research and development stage, which is why they are currently a more expensive options. We don't use them generally we don't use them. You will find that one of the researches which I found is that in 2018 the hybrid silicon solar cell in research, as I remember in journal of Nature Energy, it reached a 33.3% conversion efficiency, very high efficiency, the highest recorded efficiency. Okay, and of course it is still in the laboratory stage, it is not in the market. Okay, However, it's considered as one of the best types, and it has a very important efficiency which can help reduce the amount of panels required. Okay, so in this lesson we discussed an introduction to solar energy. We discussed the different components of a solar energy system. We discussed the construction of PV panel and how a solar cell works, and we discussed the different types of solar cells.